All right, welcome back, everybody, to the 17th week of our Tech Bytes JavaScript session. We've officially reached the 4 months and 1 week mark. Last week was our 4 month sort of anniversary, if you want to call it. And this week, we're just going to be continuing where we left off last week. In case you are coming from the web development course, welcome back to the 9th week, aka the 2 month and 1 week mark. As always, glad to have you guys with us, joining us here today. And without any further ado, let's get to it. In case you guys don't already know who I am, my name is Rian Siddiqui, guys. I'm a senior at James B. Conant High School. I love to program. I've made multiple apps for the App Store, made a dozen different websites, and I'm now really looking towards the side of content creation, making some of my own YouTube videos, working on a talk show with some of my friends. We talk about sports, writing some articles online as well. And if you want to check out anything which I've been up to, you can always go to my website at rayansiddiqui.com. All right, so let's get down to what are we actually doing today. That being that first, we're going to start off by just getting a quick update out of the way in terms of how our schedule will slightly be shifting for this upcoming month of October because school has started and all that good stuff. Then we're going to get to our daily fun fact in which we're relating the programming language which we are studying to a cool fact. And today's fact is, like last week's, pretty cool. And then we're going to discuss our calculator project, just go over what we're making, get our focus on the right idea again. And then we're going to go over the code which we wrote last week. And this week, we're just going to continue some coding some more, adding some more functionality, making that calculator even more pristine and nicer so that you can use it one day or even show it to your friends and family members. So let's get to our first item on our agenda, that being our update for the upcoming month of October. Now, guys, I'm sure as you guys all are aware, school has started, right? We are all pretty busy from the morning till about the afternoon, around 2 to 3 p.m., which is why we are pushing back, making one more adjustment. If you remember, during this month of September, we pushed back from 1 to 3 p.m. Well, starting in October, we're pushing back till 3:30, meaning our this picture, you can ignore this is like a calendar just to be there, but essentially our intro to web development course, our intro to programming course, I'm sorry, on Mondays, that will be happening not at 3 but at 3:30, meaning the day is still the same. And then our web development course will also be starting at 3:30, just to make sure that you guys can get a quick mental break in after school ends. I know I'm also a senior in high school, how it can be you just need a little while to kick back and relax, which is why we have pushed back now to 3:30, and then we will be going till around 4:30. Now, our Hack Central program, that also will be shifting a little bit, and that will be happening every second Monday at 3:30 p.m. So for this month, we tried out making it a bi-weekly program, but we are going to go back to making it a once-a-month event, which is happening the second Monday of every month. And lastly, Teen Trivia will also be getting pushed back to 3:30. So just remember that as the month of October rolls around, all of our programs will be starting at 3:30. So hopefully you can join, more people bring your friends, and yeah, we can have an even better time. All right. So let's get down to today's cool JavaScript fun fact of the day. That being that we can make apps for smartwatches using the language of JavaScript. Now, I happen to have a Fossil smartwatch. So essentially what I'm saying that if you guys can see that, if I go to my apps area, all of these apps I can make. So we can make these apps which we use on our smartwatches using the language of JavaScript. Well, how's that possible? Well, remember, we've learned how we can use JavaScript to make iOS and Android apps. A couple of weeks back, actually, that was our cool fun fact of the day, in which we were discussing the applications of our language. JavaScript is a lot. We can not only make the websites and web pages, which we do together in our Tech Bytes course, but we can also use frameworks like React Native to make apps for the App Store. And today, essentially what we're going over is that we can use this language of JavaScript to not only make apps for watches like Pebble watches and smart watches like Fossil, but also for Apple watches. Now, if you have an Apple Watch, you probably know, or any type of smartwatch, you can download apps from the designated Play Store, App Store, whatever you use to download your apps. And the way which we can make those is first, if we talk about Apple Watches, there is actually a software which Apple has made called the Apple Watch Bench, which uses some of the fundamentals from the programming language of JavaScript. And using that software, you can make iOS apps for the watches. So literally, maybe if your parents have one, maybe you even have one, you can literally use this software and our language of JavaScript, combine the two ideas to make an app for an Apple Watch. Now, it gets even cooler because if we talk about, like, say, a Fossil watch or a specifically a Pebble watch, which I got the pictures in the top right and left corner, there's actually a JavaScript framework called Pebble.js, a very unique name, right? Pebble smartwatch, Pebble.js, and that exists using the language of JavaScript. And basically, this framework made by the watch company Pebble is made so that you can make apps right away for Pebble watches. Now, for Apple Watches, it's usually a bit of a longer process in terms of developing the smartwatch app because since we all know Apple is a pretty big company, safe to say, they have a bit more standards and regulations which you have to meet in order to make sure that your app qualifies to be able to be downloaded. However, with Pebble, you can instantly make an app in JavaScript, maybe make a functionality that, hey, when I click a button, it does an animation, or maybe it's like my own spin on a stopwatch. You know, there's so many different ideas which we can have, and using this framework called Pebble.js, you can make that happen. So this week just goes to prove one more time how what we're studying, it can literally do everything. You know, through this, when we started our cool fun fact of the day over the past almost 2 months now, we've learned about how we can drive cars such as Teslas. We can make apps not only for the App Store but Play Store using JavaScript. And today, learning about how we can use that same language in order to make apps for something on our wrist. All right, so let's talk about and get back to our main project, which we have been working on for the last 3 to 4 weeks. I believe it's almost been. It's crazy how time flies. And basically, guys, if you have not already been keeping up with us, you can always go back to the Schomburg Library's YouTube channel and check out our other videos regarding the calculator project. And you can also go to the Google Classroom if you want to keep track that way as well. However, basic idea which we've been covering is that we're making a basic arithmetic operator calculator, meaning it can do addition, subtraction, multiplication, division. And the core concepts which we are once again using are variables, functions, loops, parameters, the DOM, the document object model, in which we are manipulating our HTML. And it's safe to say over the past 3 weeks, I believe now it's been, we've done a lot. Oh, it's actually been a month, I believe. Yeah, it's been a month almost now. And over the past month, guys, if we take a look at what we have covered last week specifically, we were finishing that idea of adding the functionality for our calculator to perform multi-digit operations. So that first week and a half, 2 weeks-ish, our calculator was only able to do 1 plus 1 or like 9 plus 10, 9 plus 9. It was not able to process two-digit numbers such as 10 plus 10 or 15 plus 25. Well, last week we finished that idea and using the concept of substring. Remember how we're able to extract certain letters from a variable? And basically using that concept, going deep dive and looking into how that actually works, we added the ability for our calculator to do multi-digit operations. And lastly, last week we also added the functionality of a square root button. Now, basically, remember the guys, the square root button acts as a way for us to say when do the square root of 81, that's 9, square root of 64, that's 8, square root of 16, that's 4. And once you pull up our calculator on the actual website, we can go over what we did again if you guys have any questions. But this week, we will be adding some more features. That being that we're going to be adding some trigonometry functions, such as sine, cosine, and tangent. And in case you do not know what they are, you do not worry. I will be going over doing a quick preview like I do every time we do a mathematical function. And also, we will be potentially adding a random number generator. But also something which I forgot to add here is that we're going to be adding a clear button. So right now, if you go onto our calculator, you notice that we can't, once we type in like an equation or like an operation, it stays there. We have to hit the run button for our calculator screen to refresh. We're going to take care of that today. So what I want you guys to do is hop on our JavaScript coding website. The link will also be dropped in the chat if you guys need it. And yeah, give you guys a quick minute and I'll make my way over there as well. And in case you cannot find the correct link, guys, remember our Google Classroom always has a ton of good information. You can always head on over to the classwork tab and go towards our week 16 Tech Bytes recap and just click the calculator template fiddle. All right, here we go. Hopefully you are making your way on over to our calculator. Hopefully you've been keeping along over the past month. It's been a lot, and it's truly cool to see how much progress we've made. And this week we're just going to continue keep on making that progress. And as you make your way over here, just a quick review what we did add last week. That being that now we're able to do an operation like 25 plus 30. That should give me 55. Last week, that was not the case because we did not have that ability, but that's what we worked on last week using this idea of a substring. And also we added this feature of another operation. So we can do the square root of, say, 81. That is going to be 9 because 9 times 9 is 81. There we go. And that was also a piece of code which we added last week. So this week, guys, our objective is to add 3 trig functions. Firstly, that being sine, cosine, and tangent. Now, before I do explain what each of these mathematical functions do, I want to first make the buttons in our HTML, just get that laid out. So what I'm going to do is just copy one of our old buttons, like such. Find a place where you would like to add it. I'm just going to go towards the right of the 0 button, towards the right here, populate that area, and then just paste it. Change the actual value being displayed. So I'm just going to say, we'll do sine first. And then I'm going to change the parameter which we are passing into our do output function to, we can make it the letter S, just to shorten it up. Copy this line, go ahead and paste it twice because we have 2 more functions related to trigonometry, which we're going to be adding. So we got sine, cosine, which is COS for short, and then tangent, which is TAN for short. And then I'm just going to change the parameter which we are passing in. So for cosine, change it to the letter C. And then for the word tangent, change it to the letter T, just so we know which type of function, which type of operation we are dealing with. And if I hit run now, we are able to see that all 3 of our trig functions have popped up. And whenever I click the respective button, we see that value pop up. So if I hit the sine button, we get the letter S. All right, so once we have that part added, I'm going to shift my screen on over. Oh, give me 1 second. I'm going to get my iPad. All right, guys, so now that I got my iPad connected, what I'm going to do is just get my iPad's whiteboard pulled up. There we go. All right, so before we actually add a math function, I usually like to go through what that function actually does, whether we all know what the basic arithmetic functions do. But last week we went over the square root function, and this week we're going to be going over some of the trig functions. So in case you have not heard of what I'm talking about, what is sine, cosine, tangent, do not worry. We're going to be going over it today. So let's start off with a right triangle. Now, whenever we use these trig functions, it's important to know that they work with right triangles. If we don't have a right triangle, we have to use some other types of formulas which apply like the law of sines, law of cosines, but we don't need to worry about that today. So what I'm going to do, just draw a right angle right there so we know this is a right triangle. And now what I'm going to do is write a little acronym, which I'm not sure, maybe you might have heard. That being so, ka, toa. What am I writing down? Well, basically, this is an acronym, guys, which is super useful in remembering what these 3 functions, which we're talking about today, do. Remember if I can zoom in. So this so function relates to the word sine. The k acronym relates to the function cosine, and the TOA acronym relates to the function tangent. Now, where does this SOH, what does it actually mean? Well, the first letter, essentially, it's telling us that sine. So we know that this acronym relates to the function of sine. Similarly, this k, the C means that this acronym relates to the function cosine, and the T means it relates to the function of tangent. Now, say we want to start off with the sine. So we have the word so. Essentially, what this means is sine means opposite over hypotenuse. Now, what sine? What are we taking a sine of? Well, usually there is a sine of an angle. Basically, that's a geometric symbol, guys, for representing an angle. So the sine of an angle is equal to the opposite side length divided by the hypotenuse length. Now, just to make sure that we all know what is a hypotenuse, what is a leg, the longest side in a triangle, guys, this is a hypotenuse, and this bottom side and this top left side are usually referred to as the legs. Remember, if you do not know, there is a equation called the Pythagorean theorem, which works for right triangles. So if we want to figure out the side length of h, and I'm going to actually change this to be A, B, and C, D. So A, side B, and then side C. Remember, this is the longest side. And basically, if you want to figure out what that C value is, what the length of that side is, we can do something called the Pythagorean theorem. So C squared equals A squared plus B squared. And using this theorem, we can solve for C, taking the square root of the sum of the squares of A squared and B squared. But that is a side note. Going back to this idea of sine. So say I have an angle called angle X in that top corner towards the left. And I want to take the sine of that angle. So say I know that this angle X is 45, or I should make it like 40 degrees. So if I want to take the sine of that angle, what I'm going to do is do sine of 40 degrees. And what that means is that when the sine of 40 degrees is happening, it's essentially the opposite side divided by the hypotenuse. Similarly, if we have the cosine, we have the cosine of an angle is equal to the adjacent divided by the hypotenuse. So in this case, guys, I'm going to start clearing some stuff out. So we know that the sine of an angle is opposite over hypotenuse, meaning in this case, it would be sine of 40 equals whatever side is opposite, that meaning B, or divided by the hypotenuse. Remember, the hypotenuse is the longest side in a triangle, so B over C. Similarly, if we do the cosine of 40 degrees is equal to adjacent over hypotenuse. So that would be the cosine of 40 equals the adjacent side length to our angle. Well, adjacent means right next to. In this case, that being side A. So side A over the hypotenuse, once again, that being side C. And lastly, I'm going to do our tangent right here. When we have a tangent, if you guessed it, it's opposite over adjacent. So tangent of 40 equals opposite divided by the adjacent side. And in this case, that will be tangent of 40 equals the opposite side from 40, which is letter B, divided by the adjacent side. Remember, guys, adjacent refers to whatever is right next to our angle, that being side A. And basically, if you want, we can plug this into our calculator, find out what the sine of 40 degrees is, find out what the cosine of 40 and what the tangent of 40 degrees is. And hopefully you notice that a tangent is a pretty cool trig function because we do not need to know what the hypotenuse length is. and we can just use the legs of our triangle. So I'm just gonna clear this out and do one more example. So say we have another triangle. I'll make it like this actually. Here we go, right triangle. And then I'm gonna say this side length is 10. We'll call this side length 7, and we'll call this the hypotenuse a length of 13. It could be whatever unit you want, centimeters, inches, does not really matter. Just think of them as a side length. And now we'll do 4 different problems. Or actually, we'll do 3. So letter A, we have an angle right here called angle A and an angle B. I'll rename this so that isn't confusing. So number 1, the first question which I want to ask is, what is the sine of angle A? Well, remember the acronym SO, CA, TOA. So sine means opposite over the hypotenuse. So opposite is 10 divided by the hypotenuse, which is 13. Similarly, if you do a question like, what is the cosine of angle A? Well, cosine refers to adjacent, meaning 7, divided by hypotenuse, so 7/13. And lastly, if we have a function, if you have a problem asking for the tangent of angle A, that is equal to the opposite, which is 10, divided by the adjacent, which is 7. And lastly, if you were to do this for angle B, so say I want to do the sine of angle B, remember it is opposite over adjacent. So opposite of angle B is 7 over the hypotenuse, which is 13. If we want to do the cosine of angle B, that's going to be adjacent, which is the side length of 10, divided by the hypotenuse, which is 13. And then lastly, if we have the tangent of angle B, that means opposite divided by adjacent. So opposite, which is 7, divided by the adjacent, which is 10. Hopefully, if you guys, as always, if you have any questions while I'm going through this, be sure to drop it in the chat, or you can always ping me at the Google Classroom. But that is the basic idea with these trigonometry functions. And basically, with a feature which we're going to be adding to our calculator is that we are not going to be solving for an angle. We're going to tell our calculator that, hey, find the sine of 30 degrees. So essentially what our calculator is going to do is what yields a sine of 30 degrees, what opposite divided by hypotenuse side length will get us the sine of 30 degrees. And the sine of 30 degrees is equal to 1/2. So eventually, once we start coding this, these trigonometry functions, we'll run this test and do the sine of 30 degrees. And hopefully it should give us 0.5 or 1/2. So that was a quick review of our trig functions, in case you do not know what they do. Always a good thing to go over some math, right? All right, so now let's get towards actually adding those functions. So we've done a deep dive into learning what they do. Now it's time to code them. So what I'm going to do is that since we've already made our HTML buttons in which we are passing the parameters of the 3 trig functions to our function do output, what I'm going to do is just copy and paste this last evaluation operation logic statement. Paste it once like that. And then what I'm going to change is the condition which is being checked for. So if the operation being inputted is equal to the letter S, because remember, we're passing the parameter, which is the letter S, meaning we're looking for the sine operation. And then essentially all we have to do is think about how does this sine actually work. Well, firstly, we have to do a substring of our number. Now remember, essentially when we're doing a sine trigonometry function, we only have one number. So it could be multi-digit, one-digit number. It's not like we're doing the sine of 40 plus the sine of 30 in one statement. So this statement, this first line of code which we have designating what our number is right. Because remember, this line of code is essentially saying to us that, hey, we want all the numbers which occur after our operation symbol. So in this case, if we take a look at the whiteboard, say we have the sine, I do sine of 45. The code which we have written right now what it's going to do is extract all the numbers beginning at the number 4 all the way till the end, meaning this our code would substring the number 45 and then take the sine of 45 degrees. So knowing that, we can leave that line unchanged, but the operation has to change a bit. We're not taking the square root. Remember, we have this awesome a math library in JavaScript which we can use to do the sine, cosine, and tangent of using these trigonometry functions. And basically, it's pretty simple. All we got to do is do math. So math dot sine, S-I-N, opening close parentheses, of our angle, like such. And that's pretty much it. Since we did do a lot of the code regarding our calculator using substring, it did make our lives easier this week, which is why we were able to spend a bit more time explaining the math today. And basically, all we have to do is change this one line to perform the operation, this time of the sine function. So if I hit run, I did tell you guys the sine of 30 degrees is 1/2. So let's see if that's true. I'm going to do the sine of 30 equals, oh, looks like I did something incorrect. One sec. Oh, I believe I found the problem. So in math, there are two types of units essentially. There's degrees and radians. Right now, the calculator which we are working with is in radians format. So that's why it is printing out that value, which is fine. The answer is correct. If I search up right now, the sine of 30 in radians, we will get like 0.98 negative. Yep, we get negative 0.98. So not to worry, we can always go back to that. But once we have our sine function coded, we got to use the same mentality to add the cosine and tangent functions. So copy this line of code, this whole logic statement. I will paste it once and twice because we have two more functions we got to add. Replace the letter S with the letter C now because we're doing the cosine. And now, since our first line of code is still valid, we're still extracting all the numbers which occur after we input the letter of the trig function we want to happen. Sorry, that's a lot of the word occur. And hopefully, guys, give you a quick minute right there. That's a lot of code we're doing right there. And once we have that, guys, we just got to change one word. That being the sine word. We got to change it to COS, math.cosine of our angle in radians. And essentially, once we have that, guys, we got one more trig function left, that being the tangent, the opposite divided by adjacent. Change the logic statement in which we are comparing, checking for which operation which is happening. Change that to the letter T so that we know it's the tangent function. And then change one word again, that being math.tangent now of our number. So if I hit run now, if I do the cosine of, say I want to do the cosine of 30, since this is in radians, it gives us 0.154. If I go online, do the cosine of 30, we get 0.154, which is exactly what we coded. Give everybody a minute to catch up. And as you guys are catching up, we can essentially use all of these trig functions now. So if I do the sine of 0 degrees, that should give me 0. Indeed it does, because the sine at the 0 towards the right of the x-axis is 0. Say we want to do the cosine of 0, that should give me 1. There we go. Say we want to do the cosine of 90, that should give a 0. Oh, this is the radian still, never mind. And yes, so this is another cool functionality which we have added today. A bit of a more complex, if you've not already talked about these trigonometry functions in school, but hopefully you got the basic idea down today of what this idea of trig function, sine, cosine, tangent, what they entail, and how we can use them with right triangles. Now, with this objective done for today, we got one more thing left to do, with that being that we are going to be adding a clear button. So if you take a look, if I do like a 58 minus 6, 52, I can't clear that last statement. I essentially have to always hit the run button over and over again for my screen to look nice and be formatted correctly. So today we're going to be fixing that up. So what I'm going to do is actually we're going to have to create a new function for that. So what we can do, guys, is essentially copy any of the buttons we already have. You can paste that wherever you'd like. We're not really focusing on the formatting this week, so that's fine if you want to do whatever you want. And then I'm going to create a new function in my JavaScript called clear answer and set the value equal to clear. And now if I run, we can see the clear button has indeed shown up. Once we have added that button to our HTML, we got to code the function which actually clears our screen. So what I'm going to do is go down to the way bottom, make a new function. So function, whatever you named your function in the onClick area. So clear ans, and then open and close parentheses, open and close squiggly brackets, tab in. And now, if you have a basic calculator, you know that if you hit the clear button, you usually see the number 0. So we want to make it happen that way. So we got to change and use the DOM, remember the document object model, to manipulate our HTML and change what is actually being displayed. That being, we got to manipulate the output tag. So if you guessed it, we got to use a really long line of code. So document dot get capital E element, capital B by, capital ID, open close parentheses of our output paragraph ID, and then dot, because we're manipulating our HTML, dot inner HTML equals, and I'm just going to set it equal to the number 0, like such. So now if I run, and if I do an operation like 96 minus 30, we get 66, like that. But if I want to clear it, there we go. Our screen is nice, and we don't have to hit the run button again. But there's still something missing. Essentially, right now, we're just making it look like our answer cleared. However, if I do another operation like 60, if I do this operation, hit clear, if I do 6 plus 3, notice that it worked. But there's still one thing which we should do, just as a good precaution. We have to reset the value of our numbers we inputted to 0. So our first number is numcalc1, set that equal to 0. And then set our second number, however many digits it is, equal to 0, like such as well. This is just a good practice which we should implement, guys. Although it did work right there, I could use a clear button. Adding these 2 lines of code just ensures that our values of our numbers are reset and our calculator can function properly. And now we can essentially use this calculator however much we want. I can do 23 plus 3 gets me 26, hit clear, do another operation, so I can do the square root of 81, hit equal, we get 9. And we can see that our calculator is nice and operatable now. We don't have to hit the run button every single time we want to do an operation. And that wraps up our code for this week. Guys, we are reaching the very end of our calculator project. We have made a lot of progress, and essentially we just got a little bit of code left in terms of refining our project. And essentially next week what we're going to be doing is finishing the project up. This has been our longest project yet, and it's rightfully so, because it's a lot of code, a lot of new ideas concerning math and code, combining those 2 subjects together. And yeah, next week we're going to be finishing this off, adding some finishing details, potentially even working on some CSS. And if you guys would like, we can also do a show and tell sort of thing, in which I can make a Google Classroom post and you guys can attach screenshots of your calculator, so we can go through and check out what everybody has made. As always, guys, hope you guys had a great time today. From our daily fun fact to making our calculator project, be sure to show it off to your friends and family members. Show them what you're making. It's pretty cool how we're applying our coding language. As always, guys, take care. And I'll catch you guys maybe this Friday for team trivia. Otherwise, I'll see you guys next Wednesday. Take care, guys. See ya.